This is FLOSS Weekly. I'm Doc Searls, and this week, Dan Lynch and I talk with Rand Hindi of Zama and FHE.org. But here's the thing. It's all about homomorphic encryption. This is a kind of encryption that's more private than anything we've had before. The encryption is done in such a way that you're private at the ends. And all kinds of processing can be done on the encrypted data in the middles, as it were. Here's the thing. He thinks it's going to be really big in the next several years, and he's working on this. It's really interesting stuff. We go off on a lot of tangents, but it's a new thing. It's big, and it's coming up next.
Podcasts you love
from people you trust.
This is TWiT.
This is FLOSS Weekly, episode 727, recorded Wednesday, April 12th, 2023. Homomorphic encryption, the next big thing. This episode of FLOSS Weekly is brought to you by Collide. That's Collide with a K. Collide is a device trust solution that ensures that if a device isn't secure, it can't access your apps. It's zero trust for Okta. Visit collide.com/floss and book a demo today. Hello again, everybody, everywhere. I am Doc Searls, and this is FLOSS Weekly. Brought to you this week with Dan Lynch himself. There he is with a very strong red theme there. You've got the red spit filter on your mic, and you got the hat. Not a red hat, but one with a red chicken on it.
So I mean, I suppose a little cultural note for everybody. Hello, nice to be back, by the way. This little bird on here is called the Liver Bird, and it's the symbol of Liverpool.
I thought so. It's LFC, it says there also.
Yeah, Liverpool Football Club, but the actual bird is part of the city. There's two statues of them on top of Liver Building, which is like one of our cultural landmarks, if you like. So but red's my favorite color. That's the only explanation for this. Yeah,
because you got a red lampshade in the background, and you also have a red line circling both of your ear cans.
And a red guitar that you can't see. That's just
I can see it. I can see the guitar.
Yeah, the red guitar. I do.
You need red frame glasses or rose glasses. That'd be good.
Those tinted ones. Yeah, I'm wearing my amber glasses today.
And you're also wearing your Firefox T-shirt, which I have one just like that, but much more ratty looking than yours.
This is getting pretty old now. I need to get a new one.
It used to be blue, and now it's kind of gray. Yeah, they do that.
Yeah, it was kindly given to me by somebody from Mozilla.
Yeah,
so I have to kindly ask them, see if they'll give me another one. I don't know if you can buy them.
Yeah, I worked for them for about a year and a half, something like that, back in the mid-teens. So we can make an Earth sandwich. You're in Liverpool. I'm now in Los Angeles or near it, and so we're 8 hours behind each other, or I'm behind you. You're in the future for me. So have you done your homework on this one with Rand Hindi today?
I have, yeah. I've been reading all about all the FHE encryption stuff, and I can't say I'm an expert, but that's why we have an expert guest, you see. But I do. I have been looking into this today. It's very interesting stuff. It's quite an exciting time for, obviously, privacy. It's always been important to most of us, especially I would imagine in the community around this show, but becoming more kind of publicly known at the moment, the arguments about privacy and stuff. A lot of stuff going on in the UK right now about encryption and the government wanting to enforce companies to open up their encryption. So we've got WhatsApp talking about possibly being banned in the UK. Signal have said they'll leave the UK absolutely 100% if they're asked to do anything to compromise their encryption. So it's an interesting time.
I did not know about that one. That's interesting. Mm-hmm. Wow. Well, it's all new stuff to me, and I think it's really interesting. I think it'll be really interesting for our listeners and viewers. So I'm going to introduce him. Our guest is Dr. Rand Hindi. He's an entrepreneur. He's a deep tech investor. He's the CEO at Zama, an open source homomorphic encryption company, and an investor in more than 30 companies across privacy, AI, blockchain, medtech, and psychedelics. Lots to talk about there if we want to. And he's with FHE.org, which is another interesting thing. So welcome to the show, Rand. How you doing? And where are you doing?
Thank you. Nice to be here. I'm calling from Paris, actually.
Paris. Oh, so you're even farther advanced. We can make a bigger Earth sandwich.
I'm an hour
ahead of me. Yeah.
Excellent. So what I left out of your LinkedIn bio, which is where I read it, why don't you give us more of your background, then we'll go into what Zama and FHE and everything else is about, because you say you started at 10 and made a social network at 14. Pretty cool.
Yeah, I mean, I started coding when I was 10 years old. That was in 1995. And, at the time, we didn't have all the tools we have today. I think, my first website that I built was, I don't even think we had CSS, right? So all the layout was using HTML, PHP was just the beginning. And so I started doing a lot of these things for fun. And with a friend, we started posting pictures of, high school parties that we went to on a website. And that turned into a social network, which was a great experience because the social network in the 90s looked pretty similar to what we have right now, just a lot less, fluid and a lot less fun, with a lot less people. Well, clearly. So I think, that's how I got into development. And then after that, I went to study computer science. But the thing is that I was so bored learning how to code because I had already been coding for a few years by the time I went to college. And that's when I started getting interested in artificial intelligence. So I started doing machine learning in 2003, and eventually ended up doing a PhD in machine learning applied to biology. So that was, sort of like the continuity of my interest in everything related to data. And then after that, effectively started being an entrepreneur. I did one job interview out of college. And I remember the interviewer at the end said, "Look, you're pretty good technically, but you're never going to fit in a company. You should probably start your own." And I was like, I knew it. I knew that I was like an entrepreneur. And from that point, I only started companies. So I was running a machine learning company with a focus on privacy that got acquired a few years ago. And now I'm running a new company, Zama, working on this new technology called homomorphic encryption.
So you've been in Paris or France this whole time. I see you've done a whole lot of things in Paris.
I grew up in Paris. Then I lived in London and in New York for a few years, and then came back to Paris just before COVID, actually, when I sold my previous company.
So tell us about Zama and what you're doing with that, and we can branch off in other topics from there.
Zama is a company working on a technology called homomorphic encryption. So homomorphic encryption is a type of encryption technique where you can do processing on encrypted data without actually having to decrypt it. So imagine, for example, I'm a user of ChatGPT, right? Everybody's talking about ChatGPT right now. When I'm sending a query to ChatGPT, all of my data is being processed by OpenAI's servers, right? They're the one running the actual machine learning models. And then they send me back a response and I can go back and forth. What that means is that the company who's running the service has access to all of the data of the users using that service. With homomorphic encryption, you could do the same thing, but keeping the data encrypted end to end. So I would encrypt my data on my side, on my machine, send it to the provider of the AI service. They would process it blindly, encrypted, produce a response which itself is encrypted. So ChatGPT gets an encrypted input and produces an encrypted output, and I can decrypt the output. So from my perspective, nothing changes, but now the data is encrypted during transit and during processing. And so why is that important? It's important because when you can do that, it doesn't matter if a government subpoenas the company for data. They don't have the keys to decrypt the user data. It doesn't matter if a hacker breaches the server security because there is nothing for them to steal. There is no data visible. It doesn't matter if an employee goes crazy because they cannot snoop in on any kind of data. Effectively, it removes the need to trust a service provider with the security and the privacy of the data we're sending to use the service.
Wow, it's a really interesting concept, Rand. I like it. It goes beyond we've heard a lot about people storing data unencrypted. You see these stories all the time. Somebody's got into a database and got X amount of credit card numbers, passwords, whatever it might be, because they're not storing the things encrypted. But you're going beyond that. You're saying actually, because even then people would decrypt the data to process it and then encrypt it again to store it. But you're saying it never gets decrypted on the server.
Exactly. The way we like to think about it is, how on the web we went from no encryption at all to encrypting transmission of data between client and server. So HTTP to HTTPS. Well, imagine if the data stays encrypted even during processing. So imagine if you could extend, HTTPS to end-to-end encryption for anything you do online. And this is really what we think about when we think about homomorphic encryption. We see it as end-to-end encryption for everything you do online.
Excellent. How does this affect kind of processing speeds and stuff? Because I imagine it puts more load onto your CPU, does it, in some way?
That's a great question. When we talk about a technology that sounds like a magical solution for too many problems, the question is always, why aren't we using it? And in the case of homomorphic encryption, there are three reasons. The first one is that it was way too complicated to use. Unless you had a PhD in cryptography, it was impossible for you to use this technology. The second problem is that you were very limited in terms of the kind of operations you could perform. So you could maybe add numbers, you could multiply numbers, but you couldn't run a database on encrypted data or run a machine learning model on encrypted data. And finally, the third problem is performance. It basically takes about 1 million times longer to process data encrypted than if it's not encrypted. So, great idea, but if something that used to take a second now takes 11 days, it's not exactly user-friendly and web scale, if you think about it. So these are exactly the things that we had to figure out in our company, effectively by building tools for developers that makes it easy to use homomorphic encryption, even if you know nothing about cryptography, while also working on making the technology able to do any kind of computation at a much, much, much faster speed.
Excellent. I was reading it earlier on. Your docs are really good, by the way. I love the stuff you've got on the website. It was great, even for someone who's not an expert in this. For me, I found it really fun to read some stuff. I loved that one of your blog posts started with, "I must confess I've committed a crime." And I'm gonna. It's like watching a film or something. I was like, I'm gonna have to see more of this. I want to know what happens. But yeah, it was really good. But I was looking at the stuff you were saying about. It could be maybe 5 years or so before the kind of the hardware catches up. Is that a fair kind of time frame?
Yeah, I think 5 years is the timeline we have in mind for being able to run a very large AI model like ChatGPT on encrypted data. Because, this is kind of like the worst case scenario of what you want to do encrypted. The hardware, which is going to be accelerating homomorphic encryption by 1,000x at least, is going to be available in a couple of years. But we think we need a little bit more than that in order to get to large language model AI scale usage. But in the meantime, we can do many other things, right? We can already use homomorphic encryption for blockchain, because a blockchain is a slow, expensive computer that actually runs very simple programs. So it's kind of like the exact opposite of AI in the cloud, where things are huge, fast, and cheap. So we can run smart contracts in blockchain using homomorphic encryption today. You can also use it for all kinds of smaller scale applications, retrieving a valued and encrypted database, or filtering images encrypted end to end, and even maybe doing spam detection on your encrypted emails, for example.
Excellent. I was when I was reading through your stuff before, I noticed that I was thinking about the whole quantum computing situation and how that could impact all of this. And I noticed in your documentation it said that homomorphic encryption helps to mitigate against attacks from things like from quantum computing and stuff. Can you tell us a little bit about that and how that kind of stuff works?
It doesn't really help mitigate against quantum computer attacks. It's just that homomorphic encryption is a scheme which is post-quantum. What that means is that even a quantum computer cannot effectively break the encryption itself. So if you look, for example, at RSA, which is based on factorizing large numbers, a quantum computer can factorize number very efficiently. So that's why RSA is broken with a quantum computer. But homomorphic encryption like the other, by the way, new standard for post-quantum cryptography, are using a different type of mathematical problem, something called learning with error, which effectively makes it impossible for even for a quantum computer to break this encryption. Like there is no algorithm that you can figure out with a quantum machine that could break that, at least not that we know of right now.
Mm-hmm. And would I mean, we talked about the advancing hardware will make this stuff easier to do the encryption as a process. Would quantum be applicable in that realm as a way of speeding up what you're doing for servers and stuff?
Absolutely. The main bottleneck when you're doing homomorphic encryption is computing what's called a Fourier transform. So effectively, you're trying to multiply two large polynomials, which are two vectors of numbers. Mm-hmm. So you take two list of numbers and try to multiply them very quickly. That takes a while if you do it, element by element. So you use something called a Fourier transform. A quantum computer can actually do a Fourier transform very efficiently. So honestly, I'm actually looking forward to quantum computing, not because of everything that it will break, but for everything it will speed up.
Yeah, that's a great point, because a lot of people, I mean, I have some friends who are very into cryptography, some mathematician friends and stuff, and they're, we had a discussion about this actually at a Linux user group not so long ago, and lots of people were worried about it. You hear a lot of fear mongering and stuff about the quantum's going to destroy encryption. It's going to, once people, the hackers have got quantum capabilities in their computers, they're just going to cut through all our encryption. But it sounds as though it's a good double-edged sword. It's going to work both ways in some ways.
Listen, if in 10 years you didn't upgrade your system to move to a post-quantum cryptographic scheme, then you're probably not very good at security and you deserve to be hacked, honestly. I mean, I know it's a terrible thing to say, but imagine if you're not patching your servers for 10 years. You're going to get hacked for sure. So it's the same thing with cryptography. Cryptography is broken. You have to upgrade to a new modern way of doing cryptography, which is better. And it's the same thing here. So I'm not afraid of quantum computers. In fact, I'm investing in companies doing quantum computers. It's something I've been actively looking at. I'm very excited about the promises of that technology. I think every problem it creates, we can figure out with new technology. So
I have some timeline questions, but first I have to let everybody know that this episode of FLOSS Weekly is brought to you by Collide. That's Collide with a K. Collide is a device trust solution that ensures unsecured devices can't access your apps. Collide is the big news. If you're an Okta user, Collide can get your entire fleet up to 100% compliance. Collide patches one of the major holes in zero trust architecture, device compliance. Think about it. If your identity provider only lets known devices log into apps, but just because a device is known doesn't mean it's in a secure state. In fact, plenty of the devices in your fleet probably shouldn't be trusted. Maybe they're running on an out-of-date OS version, or maybe they've got unencrypted credentials lying around. If a device isn't compliant or isn't running on the Collide agent, it can't access the organization's SaaS apps or other resources. The device user can't log into your company's cloud apps until they've fixed the problem on their end. It's that simple. For example, a device will be blocked if an employee doesn't have an up-to-date browser. Using end-user remediation helps drive your fleet to 100% compliance without overwhelming your IT team. Without Collide, IT teams have no way to solve these compliance issues or stop insecure devices from logging in. With Collide, you can set and enforce compliance across your entire fleet, Mac, Windows, and Linux. Collide is unique in that it makes device compliance part of the authentication process. When a user logs on with Okta, Collide alerts them to compliance issues and prevents unsecured devices from logging in. It's security you can feel good about because Collide puts transparency and respect for users at the center of their product. To sum it up, Collide's method means fewer support tickets, less frustration, and most importantly, 100% fleet compliance. Visit collide.com/floss to learn more or book a demo. That's KOLIDE.com/floss. That's KOLIDE.com/floss. So Rand, when I look at the Zama website and I look at the banner across the top, the menus there, I'm used to seeing products right up top with most companies, right? And I see community, you've got a lot of that, documentation, GitHub, and more. And there's a lot of great explanation there. And I'm wondering you said that it's going to take several years before homomorphic encryption becomes normalized for a variety of reasons you just listed. What are the landmarks here, and what are you looking at for the business of Zama as it slowly moves or rapidly moves toward whatever it's going to become?
Homomorphic encryption is not a new idea. Actually, it's been theorized in the 70s by the inventors of RSA, because RSA is actually homomorphic when you use a specific version of it. So it's something people have been wanting to build for a long time. My co-founder, Pascal Payet, is also a very famous cryptographer who invented the first additive scheme in the 90s. So the first time you could add encrypted numbers homomorphically. And so the holy grail was, can you actually do additions and multiplications on encrypted data? Because if you can do that, you can basically compute anything. And that only happened in 2010 with someone called Craig Gentry at IBM at the time, who invented the first fully homomorphic scheme, meaning you could do both additions and multiplications on encrypted data. So this was a huge revolution because nobody knew if this was even possible. So from that point, it was a whole bunch of new schemes that were much, much faster. And the one we built at Zama specifically is called TFHE. And it's like a modern way of doing homomorphic encryption, which is much faster and much more convenient than what existed before. So like the timeline right now is we are with a homomorphic encryption where AI was 10 years ago. The technology works. We figured this out. We're building the tools. And now we have to think about the use cases and applications and make that, mainstream. And this is what's next for Zama, effectively. So when we started a company, in 2020, we had a choice. We could either build a specific business case that was applicable with the state of homomorphic encryption at the time, or we could make a long-term bet that this technology was going to be used everywhere eventually and focus on building tools for people to use this technology in their applications. In other words, instead of addressing companies, we're addressing developers. And so this is why the company isn't like, a product solution enterprise kind of navigation bar. It's really a developers first company. Everything we do, we open source. Everything we do, we try to maximize the developer experience so that this technology gets included in as many things as possible.
Wow, there's it's interesting to me that you're saying that it's going to be universal at some point. And I'm old enough, so I remember. One of the first clients I had was in the early 80s, and it was a fiber company. It was called Fiberland, and they were saying fiber is going to be everywhere, right? That was 40 years ago, but it is now. Functionally, it is. The first time I actually did some work in Paris in the mid 90s, and at that time Cisco had one, I think, 500 megabit fiber line crossing the Atlantic that they were working off of, but now it's coming to many homes and it's the rest of it. But the same has happened with, I remember George Gilder in like the mid 90s saying, data is going to be free, never charge for data. They're going to have abundant data. We're going to have abundant speeds. We're going to have abundant processing. I just got a new laptop I'm working on here. It's got, I don't know, is it a trillion transistors in it? Something like that. And now we saw it with blockchain to a limited extent, but really with AI now. So we have giant AI and everybody, the tops of their heads are coming off because they're thinking what can be done with AI. And encryption, or it's been one of those words that's been around for a long time. I worked with Phil Zimmerman on PGP 1,000 years ago also, when he had briefly had a company and he was busy fighting RSA at that time. But encryption, it's really interesting to me that I hadn't heard about homomorphic encryption already. You've sold me on it. Now I can see how it moves problems into new spaces and solves it in some others. But I'm really interested in how community is being developed now, because that's what you're looking for. You're looking for scaling community, which is really interesting for us because that's what we've got here. Right. So this is a bit of a sales call for you. I hadn't thought about it that way before the show, but that's really what's going on. If this is the future how do you sort of onboard this, have it fan out into GitHub and turn into business? I mean, it's interesting to me also how many businesses you're investing in. So tell me how is community happening? It's hard to make. I mean, I've seen so many. I've covered so many communities with Linux Journal. They're all different, and even within sub communities. And you can fork everything, and those turn into new communities. So how's it going for you with that?
The nice thing about homomorphic encryption is that because nobody actually could use it, there are very few people who were actually in this community to start with. So when we started a company, there was maybe a couple hundred people in the world interested in this technology. Now there are a few thousand. So it was very easy to get everybody around the table very quickly. But building, an open source community is very hard. It's something I've done in my previous company as well. And it requires exceptionally good libraries, code libraries that people can use. So if you don't think about developer experience the same way you think about user experience when building a consumer product, you're going to make the job of a developer hard to integrate this. And nobody likes to do hard work. People like to do pleasant work, right? So, that's the first thing we said. We said, we have to make this so easy that a developer who never heard about homomorphic encryption can integrate it in their products without changing anything about their habits. So that means, for example, being able to take Python code and convert it into a homomorphic equivalent so that you don't have to learn a new language. That means, automatically integrating with a whole compiler toolchain so that, you can convert your machine learning model into a homomorphic equivalent without actually changing your toolkit. So that's the first thing, making it easy and fun for developers to use. The second thing is, and I know this isn't sexy, but it's documentation. Look, I've been a developer my whole life. Every time I had to learn a technology and I looked up the documentation and I see something like impossible to understand that isn't comprehensive, you're like, okay, maybe if it's my job and I have to do it, I'll have to learn it. But if I want to do it, like to try it and to have fun, I'm probably going to give up. So I think, documentation is like if you have bad marketing on your website, people are not going to try your product. If you don't have good documentation, developers are not going to try your library. So I think that's like a super critical part. And finally, to be honest, you just have to want to be involved. I think the fact that I'm a developer and I'm the CEO of the company, it just creates a culture of like wanting to do what's right for our users, which are developers. And that means I like to hang out with developers. I like making demos. I like, answering support questions on Discord when people are trying to do something, because, it's what I would have liked if I was on the other side of the table. And I think if you have that, honestly, you can start growing an organic community of people who believe in what you're doing. And then, from that, marketing takes over and then it becomes, a bigger machine. But the initial part, the first 1,000 users of your product or service, it has to be organic. You cannot pay for them.
It's a really interesting point. I think you mentioned that this has grown from, say, a couple of hundred people who were interested in it when you started off into like a few thousand, and then that could snowball into more. I'm interested in I think among developers, among tech people, we love the idea of encryption and privacy and all the rest of it. But I was mentioning to Doc earlier about the kind of, without getting political, about the situation in the UK right now where the government is trying to effectively outlaw encryption in some places. And that's a bit dramatic, but you know what I mean? The whole classic arguments that we've had in the past in other places where the governments and other large entities have said, we need backdoors in your encryption and so on. Is there a kind of I'm trying to think of a good word for it. Is there a kind of a public kind of mindset that needs to change? Do we need to win kind of hearts and minds of people to the idea of privacy in a way? Do you think that's something that could happen? And how does that intersect with, say, business? Because I was thinking about, say, like you mentioned, models, examples such as voice assistants, for example, like, I don't know, like Google, let's say Google's got a voice assistant they have. What's the, incentive for somebody like Google to say, let's make all of this private with homomorphic encryption, when a large part of their business is getting your data and possibly selling it or using it to advertise to you and stuff like that. Is there a kind of a case that you have to win people over a little bit there somehow?
So the thing about businesses is, the nice thing about homomorphic encryption is it doesn't prevent you from using data. You just use it without seeing it. So you could still, do a personalized recommendation. You could still do advertising, which is targeted. You're just not going to know who you're targeting with what. So the user would still get the targeted ad. It's just that Google wouldn't actually see the data of the user and wouldn't know which ad it actually sends to the user. So that's important. Homomorphic encryption doesn't prevent any data usage. It simply removes the need to secure the data. So it's a solution. It's not like something that prevents you from doing something. But let's put that aside for a second. I actually don't believe that people should care about privacy. I know that's a bit of a contradictory thing when you're running a cryptography company, but a lot of people believe that privacy is something you have to take into your own hands. I don't buy that. I think that people shouldn't care about privacy, not because it's not important, but because it should be guaranteed by design in every product they use. And so the question is, who are building those products? It's not companies, it's developers in those companies. So really the person you want to convince is the developer. If developers believe that privacy is necessary for their users, they will push to put privacy and cryptography in their products they're developing. Developers are the enablers of privacy, not companies, not governments, not people, developers. So if we do our job right, developers will push back against governments. People will not even know it's happening. The same way, by the way, that, with the first crypto wars, Doc, you talked about Phil and PGP. Remember the cypherpunks in the 90s when they pushed back against the ban on encryption from the US government, with the Clipper chip and all of that. It wasn't the mainstream people that cared about that. You didn't have like people in the street pushing against that saying, hey, let us encrypt our data. It was cryptographers. It was developers. It was, technologists that pushed against it and that won and that forced the government to change their stance. It's exactly the same thing now. Exactly the same thing now. This is just the crypto wars of the 90s, just a second time over.
Yeah, it's like the sequel, as you say. It's a sequel. Yeah, definitely. I wanted to kind of give you some space to make that point, because obviously on this show we strongly believe in privacy and so on, but it's something you hear a lot now from politicians and other people, that it's the old classic argument, you're not doing anything wrong, you don't need to hide it and all that rubbish. But there we go. So I'm interested in the tools. You talked a little bit about developers, getting them involved and stuff. And I had a look through your GitHub stuff and all that you've got on there, which is really great. And you've got a few different things on there that I thought it might be worth kind of talking about or highlighting. First of all, you've got a product called Concrete, or a project called Concrete, which is really interesting. It's kind of a compiler for all this. Can you tell us exactly what it is and how it works, or give us an overview?
The idea of Concrete is that we take some high-level code, Python, for example, and we automatically convert that into a homomorphic equivalent, meaning we convert that into a circuit of cryptographic operations that you can run on encrypted data. And so it's a compiler because it takes some high-level language, converts it into some intermediary representations, in this case, like a homomorphic representation. And then it compiles that to binary code for whatever target hardware you're using, GPU, CPU, ASICs in the future. So effectively, by using a compiler, you remove the need for the developer to learn all of the underlying layers of cryptography and to optimize the hardware. You basically just tell them, hey, just write Python code like you always did, and literally just add this one line function to your code, which is compile circuit, and you're done. That's it. That's the only thing you have to change.
Excellent. And what's the kind of adoption been like for that? Have people taken it up? Developers interested in this?
Definitely. It's pretty much exponential. It's not as big as AI as a field yet. So I think, it's still going to take us a few years before we get 100,000, people using it. But we went from 0 to 3,000 people using it in a year and a half. So that's actually pretty fast when you consider that this is such a niche new technology. So I'm very, very confident that we're going to see more and more developers start to use that, especially now that we've got those tools available. Right?
Yeah, definitely. That was one of the things I was so impressed by, is the tools that you've got on there, which you talked about leading developers towards that kind of thing. I was really interested in you've got the Rust implementation as well for UI stuff, which is quite cool. That looks really cool.
Rust is my new love. My new love. 2015. Like everyone in the 90s, I started coding, learning C and C++. And that was great at the time, I have to say, honestly. But it wasn't really meant for modern applications. So eventually, I moved out from C++. I started doing some Scala, which was really nice as well. Scala is a beautiful language. But if you want very high performance, you have to use something more low level. And the JVM that Scala is targeting is not as good as, just running code directly in the machine. And so when I found Rust, it was like obvious, like Rust is like C++ performance with all the modern features of a language and the kind of like fun that you would get with like functional, strongly typed languages. So like in my previous company, we started doing machine learning in Rust. So when we started Zama, it was a no-brainer that the cryptography should be in Rust. But even beyond that, even beyond just promoting Rust as a language, if you think about what breaks security, it's often memory issues, honestly, right? Even OpenSSL recently had a memory buffer overflow discovered, like OpenSSL, like everybody's using that, right? So moving from C, C++ to Rust is a way to also solve that problem. So I think, if you're going to be writing cryptographic code where you need performance and an extremely high level of security, then you don't want to have to think about memory issues in your code on top of it.
You brought up, since we're on Rust, an earlier show, we talked about the controversies going on right now around the Linux kernel, where a lot of people want Rust in the kernel for the reasons you just gave, I think. It's closer to the metal and all that. And opposition to it by Linus himself to some degree. Do you have any thoughts about that? I mean, or it might just be, fit to purpose, if the purpose is good for that, works. I just wonder if you had any thoughts about it.
I think anything that goes into the Linux kernel has to be thought about extremely well. It's, you're changing something so fundamental that, you cannot afford to make a mistake. And rewriting the whole kernel in Rust could be done, but it's years of work that you need to potentially recheck because the kernel code has been checked and rechecked, right? So there is a kind of saying in engineering that if it works, why change it in a way? However, new features could be built in Rust. There is no reason to use C++ to build new features into the kernel. You could write them in Rust directly, but then you have the issue of interfacing between C and Rust. And while this is completely possible and it works fine, it does add quite a bit of complexity, right? And it's not necessarily very well integrated into all of the tool chain for building, for CI, for all of those things. So I think there's still a little bit of C Rust interfacing work that needs to be done if you want to build large projects that combine both languages. But I mean, hopefully, that's something that's going to be solved. Anybody doing Rust has that issue. We have that issue, by the way. Our compiler uses a framework called MLIR, which is in C++. So we literally have a C++ compiler framework compiling Python code into Rust code and calling a Rust library behind the scenes. So it's doable, but our compiler is nowhere near the level of complexity of Linux, right? I think we're talking about very different code bases here.
Yeah, there's a lot of lines in the kernel, obviously. So one thing I noticed, Rand, when I was looking through your stuff was you've announced a second round of the bounty program that you guys are doing. Seems to be going really well. Can you tell us a bit about that? And if people are interested, how they could maybe get involved?
Yeah, actually, that's part of how to also engage more with the community. Usually when people think about bounty programs, they think about security bounties. You find a bug, you report it, and you basically get a bounty. But we think about it as interesting problems for people to solve as well. So it's more of a quarterly competition. So every quarter, we put out a list of interesting problems that people can solve. So it could be building an application using, homomorphic encryption. Like, for example, we were asking people to build a regex engine in FHE. Cool use case, right? You need that if you want to do any kind of encrypted string manipulation, for example, all the way to, improving the cryptographic primitives in the open source implementation, to even, building FPGA acceleration for homomorphic encryption. So depending on what you're interested in, you can try to solve one of those bounties. and basically get your work integrated into our stack, as well as, of course, getting the prize. And the prize, it goes from, $1,000 for writing a tutorial that we put on our blog to $100,000 if you're solving one of the bigger problems that we're currently working on. I think we even have a bounty where you can get like hundreds of thousands of dollars, depending on how good your implementation is on acceleration, for example. So yeah, I think, the bounty program, if you're trying to learn FHE, it's a great way to get started because you'll have like a bunch of cool challenges to work on. If you're a cryptographer doing this professionally and you want to like try new ideas, there are more complicated ones that could, be a good use of your research time. Or, if you just have a cool idea and you need a side project, take a shot. It's fun and potentially quite profitable as well.
So I want to go a little bit further into FHE as an ecosystem and all, but first I have to let people know that we have this thing called Club TWiT, and Club TWiT is a great part of the way our entire network works. Joining it's a great way to support the network. As a member, you get access to ad-free versions of all the shows on TWiT, as well as other benefits. There's a bonus TWiT Plus feed that includes footage and discussions that didn't make the final show edit, as well as bonus shows we've started, such as Hands on Mac, Hands on Windows, Ask Me Anything, and Fireside Chats with some of your favorite TWiT guests and co-hosts. And because I haven't mentioned Linux yet, this is important. As FLOSS Weekly listeners, you may be interested in checking out another Club TWiT exclusive show, the Untitled Linux Show, hosted by our own Jonathan Bennett. So sign up, join Club TWiT. It's only $7 a month. Head over to twit.tv/clubtwit and join today. And we thank you for your support. So I wanted to go back to, you've mentioned FHE a number of times. FHE.org is this website. You've got a conference, you've got talks, you've got meetups. You mentioned earlier about working with communities. So tell us a little bit more about how FHE works and how you're integrating that with Zama.ai as well.
FHE is just the acronym for fully homomorphic encryption. So that's how, we call that. It's like AI for artificial intelligence.
I see.
For homomorphic encryption. And when I started a company, I was thinking about a good way to rally the broader community, not around the company Zama, but rather around homomorphic encryption. And so very fortunately, to be honest, I was able to put my hands on the FHE.org domain. You don't get those 3-letter domains, for sale that often, especially not for such a low price, to be fair. And so I was like, let's just build a community around that. It's a good name. Let's just start doing meetups. And so initially it was just a monthly meetup, people talking about homomorphic encryption, presenting a paper, showing a demo. And that grew very quickly, from 100 people the first time to 1,000 people, 6 months later. And at that point, we're like, okay, let's try to put more resources into this community so that it's not just a meetup, but is really the central focus point for anybody who's interested in homomorphic encryption. You want to learn about homomorphic encryption? Go to the FHE.org website. You'll have a bunch of resources to get started. You've invented something new, you want to present it? Come to one of our weekly paper sessions and talk about it to all other cryptographers. We have a yearly conference as well that we do physically. So for example, this year is a month ago, it was in Tokyo. So, really fun places each time as well. And really FHE.org isn't Zama. It's just that we effectively moderate it and pay for it pretty much. But it's something that's completely open. Anybody could participate.
So I find myself imagining as the real Internet of Things, not the Apple, Google, and Facebook of things, and the Google of things, but the real Internet of Things, where all of our property, the microphone I'm talking to, the loose keyboard, the other things, become members on the Internet, and encryption happens between them, but the encryption becomes homomorphic. At some point, that success you're talking about is going to take, a few years to happen, but will happen, is going to involve a lot of big companies. Mm-hmm. And they're going to be doing things. They're going to be part of your community. And then the Linux Foundation shows up. And the Linux Foundation says, all these big companies are all developing things their own different ways. mind if we take over this FHE.org thing you've got? That's sort of I'm not saying that's a bad future. I think that is a typical future for anything that starts to take off. We're seeing it happen right now with personal wallets as self-sovereign identity is taking off as a thing. There's the Open Wallet Foundation. And in fact, I joined the Open Wallet Foundation for the purpose of making sure they care about individual people and not just about big companies all fighting each other. So I'm wondering if you've imagined out how that goes as the community grows and your events grow.
Our main event for FHE.org, I think that's a good testimony to how little Zama is biasing this. We had 16 speakers. Only one of them was from our company. Effectively, anybody can speak. You just have to submit a talk proposal, and there's an independent committee that isn't from Zama choosing who's going to speak at the FHE.org event. And so this year we had people from various universities. We had people from one of our competitor talking at the event that we actually host and pay for. Try to imagine that. We had people from Google, people from Intel, people from, all kinds of companies. And this is great. This is what we want. We want this to be about homomorphic encryption. Zama is just very fortunate to have the resources and the money to make this take off. But down the line, I'm really hoping that this will end up as an independent organization and foundation with its own budget and its own people, kind of the same way that, Rust ended up having the Rust Foundation spinning out of Mozilla down the line, right? You could imagine that. So Zama is incubating FHE.org, but eventually we're hoping it's its own thing. And whether we partner with the Linux Foundation, with Apache, or with someone else, that will depend on how much reach in terms of developer that can bring. The more people are using homomorphic encryption, the better, I think, down the line. But again, it's about developers. This isn't a community about companies. It's not a community about business. It's a community about cryptography and about using cryptography in your products.
That's very, very cool. You've probably just answered this, but I'm going to ask anyway. You mentioned competitors there and other companies and stuff. Are there many other companies in this space that I'm not expecting you to name them necessarily, but are there other people doing this?
There are many companies actually, especially now. I think I would say there are three main companies. There's a company in Korea and a company in America. Great people. All three of us, have raised a lot of money, and we all have great cryptographers on board. So I think that we're equivalent in terms of technical capabilities and in terms of skill set, but we're very different in terms of strategy. We are the bottom-up developer first company. The American company is a top-down enterprise company. The Korean company is more of an academic company right now. They're a little bit younger. And even though everybody wants to make a ton of money eventually, because that's the point of a company, let's be honest, we're just having very, very different ways of getting to that point. And even once we get to that point, I like them. They're good people. They're nice people to hang out with. I think we're going to share the market more than compete on the market. This isn't a winner takes all kind of market. I think this is going to be split between two or three main players and a bunch of smaller players eventually.
Excellent. I was thinking about applications for this technology. You mentioned a few. You mentioned some already on your documentation on your website. You mentioned a lot of potential future ones. Can you think of an interesting or maybe outlandish kind of future possible application for this that excites you that you want to tell us about? So
I think short term, blockchain is a perfect application for that. Long term, AI is going to be the most, I would say, impactful use of homomorphic encryption. Why? Because if you're going to be talking and sending data to artificial intelligence systems all the time, everywhere, right? You need to make sure that your data is secure. So there is I don't believe that there is mass adoption of AI on the scale that is necessary for this technology to really bring its value unless you figure out privacy. And this is what's happening now. Italy is banning ChatGPT because of privacy. There are a bunch of people having data leaks because the data they sent ended up being used in the training set, which reappeared in a prompt from someone else. Like you need to figure this thing out. And this is what homomorphic encryption does. But this is going to take a little bit longer because of the performance requirements. So I estimate that ChatGPT is doable homomorphically in 5 years. Mm-hmm. In the meantime, you can do smaller machine learning models. You can do that today with our tools. But long term, if you want like ChatGPT encrypted end to end, that's 5 years. Short term, blockchain. Why? A blockchain by design is public. Everything you do, every piece of data, every computation is public because you need, the people doing the computation to agree on the result. And so the way they did that is just sharing the result publicly, right? So that people could verify it. But that prevents you from having confidential smart contracts. So for example, if you want to hide what assets you own, or if you want, to do like a sealed bid auction, you want to bid on something without everybody knowing how much you're bidding because otherwise it's too easy to outbid you. If you want to, do finance on the blockchain confidentially without everybody knowing what you're trading and what you're doing, or even simple things. If you want to play poker on the blockchain, you need to hide your cards, which you cannot do right now. So I think blockchain has a strong need for confidentiality and privacy right now. And because blockchains are slow and expensive, and because smart contracts are very simple programs, we can make it work even without an accelerator. So blockchain is a perfect early adopter for homomorphic encryption. Machine learning and AI is the large scale, long-term kind of like use case that we really need to crack for humanity to be better off.
Excellent. I'm thinking about, possibly because of the stuff that I tend to get involved with, like edge computing stuff as well. I know obviously you wouldn't be processing, because we talked about the need for fast hardware and stuff. You're not going to be processing stuff necessarily as quickly on IoT devices, things like Doc mentioned. Is that a challenge for the future? Maybe something that could effectively,
So I used to do a lot of edge computing, by the way. In my previous company, we used to do machine learning on the edge, specifically for privacy reasons. So our kind of like idea was, well, if we cannot protect the data on the cloud, let's just not send the data to the cloud and process it locally on the device. So, we were the first company, for example, to show how you could do a voice assistant. So kind of like a Siri, Alexa on a Raspberry Pi, for example. So, you could do it on like your washing machine, your TV. And that company got acquired, by the way, by Sonos, was one of our customers. And now your Sonos actually uses an edge-based voice assistant, which is the technology my previous company built. But sometimes you cannot run the computation on the edge because maybe you need multiple users to participate in the computation, or maybe because the computation is too big to fit on like a washing machine or like a small edge device. So you still need to do stuff in the cloud. Otherwise, we wouldn't be using the cloud. And this is where homomorphic encryption comes in. So I think, it's not about edge versus cloud, right? Here it's more about whatever you can do on the edge, just do on the edge. That's less stuff to do in the cloud. That's better for everybody, right? But if you need to do something in the cloud, we have to enable you to do it privately. So, one example of that is, for example, all of those health connected devices. You have an Apple Watch. I've got like an Oura Ring. I've got like a connected scale. All of these things are connected to a dashboard, which is in the cloud. And you need that dashboard to be in the cloud because you're pulling data from multiple devices. So it's impossible to do that on the edge. Like it has to be in the cloud. Well, that is a great use case for homomorphic encryption. Just your device could be sending encrypted data. You aggregate everything. You do all of your computation in the cloud encrypted. So you do all of like your machine learning, prediction, statistics, trend lines, all this stuff you want about your health. And you decrypt it in the browser directly of the user. So you're keeping the encryption and decryption on the edge, but all of like the computation and kind of aggregation of the data, which has to be done in the cloud, is now done privately with homomorphic encryption.
We're getting down toward the end of the show here, and I want to at least visit. You've got a wonderful Substack, which is it talks about your deal flow. It's called Deep Tech Deals. You're involved in a lot of deals. I'm impressed by that. And if I see a theme, there's one is that, as you put it, you're very long on Ethereum, and I think because you can program on it. So let's visit that at least briefly, and what your thinking is about where that goes and where cryptocurrency goes. Cryptocurrency is kind of in a doldrums now in the public imagination, but I don't think it is among developers. So just visit that for a couple minutes and we'll see what we got.
Sure. When I sold my previous company, I was fortunate, to make some good money out of it. And I was like, what am I going to do with this funding? I could put it in a bank, but at the time it was like negative interest rates. So obviously that's not going to happen. I could put it like all in stocks and crypto, but that's like super volatile. So it's like, you know what? I'm going to invest in companies that I would have liked to build myself, but I just don't have time to because I'm already building something anyway. And so if you think about that, my personal interest is really in science and technology. I'm not a consumer guy. I don't know what's the next good, social network to build. Like, I don't know how to build the next TikTok, but I know what's going to be needed for all those things to exist. And so I identified a few key trends there that I think are fundamental for the next decade. So one of them is what I call, the end of Moore's law. What comes after, the CPU? At some point, you cannot miniaturize a transistor anymore, right? You're not basically getting the power out of just putting more transistors on a chip. And so what comes after that? Quantum computing, photonics, but also open source silicon, right? RISC-V, for example, super interesting ecosystem that's popping up. And more generally, I would say like the unbundling of the CPU. If you take everything a CPU does and you put that into a specialized accelerator, with a CPU core in the middle, that's very powerful, right? So what if it wasn't just a CPU and a GPU, but like more of like your chip on your Apple M1, the Apple M1 chip, it has 32 co-processors. The CPU does very little of like the heavy lifting because you've got specialization. So I'm looking a lot at that future of computing and of Moore's law. The second thing is cryptography and blockchain. It's pretty obvious to me that the concept of programmable money and the concept of like programmable assets in general is much better than like, paper pushing type of like finance and stuff. Like, I don't understand why I still get paper receipts. I could just get literally like an NFT as my receipt for everything I'm buying. That would be so much simpler. I don't understand why when I make a bank transfer, it takes 5 days to go to the US. Why? What is happening during those 5 days? Like, someone explained that to me. And so when you think about money as a programmable entity, that opens up so many things. It just streamlines so many of the rails of society that it's pretty obvious that, this is something that's going to be, everywhere. I don't know if this is going to be Ethereum or Bitcoin, or if it's going to be some government's, digital currency that's going to be adopted, but it's still going to be running on some programmable, system. So big bullish on that. So privacy, of course, very, very important. Privacy, I think, is something that I've been very passionate about since I've been a teenager. So very bullish on that. And finally, super bullish on frontier health. I think, COVID has woken up the world to the fact that healthcare doesn't work, at least the way we've been doing it. We've been, too slow in innovating on, healthcare. And so now that people realize that, there is a huge push to modernize everything. Better diagnostics, better treatments, better vaccines, better mental health, therapies. Everything is being overhauled. And that's like super, super exciting as well. So yeah, I think, for me, I'm investing in what I'm hoping is going to be an extremely technological driven future. Where we don't have any of the limitations we have right now. So yeah, it's faster machines, better infrastructure, and just, live a very, very old, very, very happy, and very, very good health.
Wow. Well, we're down pretty much at the end right now, and Dan and I have been sharing it back and forth questions we still want to ask. I have one about your portable MRI. You were talking about healthcare as one of the things you've invested in or toward. Frontier health, even to talk about that. I'm in the US where healthcare is horrible. And the data side of it is especially bad. I live in 4 places. I have 4 sets of doctors. They communicate by fax if they do it all. So there's just a lot we can continue to cover there. Is there anything we haven't asked you could answer real quickly in the last minute or so, and then we can wrap?
I mean, I think it's good. I mean, this was interesting. I think perhaps maybe I just want to reiterate something which I think is misunderstood and important. Developers are the ones who decide which technology gets used and which doesn't. Regulators, they try to make sure people don't misuse it. Consumers, they don't care. They just want something better, faster, cheaper, right? Companies, they just want to make money. Developers choose which technology gets used. So if you really want everybody to have privacy, the real thing you have to do is convince developers that privacy is important. Developers are the guardians of privacy for everybody else.
Back when Netscape open sourced their browser, which eventually became Mozilla, actually was completely rewritten as Mozilla, but when they open sourced it, I had a long interview with Mark Andreessen when he was still at Netscape. And he had this one-liner he just dropped in the middle of things where he said, all technology trends start with technologists. And it's like, it's the most obvious thing, and yet it's so easy to forget. And all the policymakers and all the business people think they're in charge of it, and they're not. The geeks run the show.
Exactly. Well, we run the show in secret, right? We're the one who decide where the future goes.
It's a secret society that could not be more public. It's just the weirdest thing. And those are our listeners and viewers. So there we are. We always close the two questions, which are silly but interesting. What are your favorite text editor and scripting language?
My favorite text editor is, I'm still using Sublime Text. I think, that's fine. It's great. And what was the second question? Sorry.
Oh, scripting language.
Well,
that was the tone.
Yeah, I guess I suppose I would say Python.
Python, yeah. Okay, that's great. Well, listen, we often, if not always, say we have to have people back, but you're on a topic that even our back channel says we didn't know about that, and they're entertained by it and energized. So that's a good sign. We will have to have you back in a year or something. And
we can talk about all kinds of crazy deep tech stuff as well. We can talk about healthcare, and we can talk about that as well.
It's just, and I'm going to subscribe to your thing. I mean, it's you seem to have a post a month. That's a pretty good pace. The ones that are daily, the big things happen not on the daily scale, but there's a different pace to it. So thanks so much, Rand. This has been really great, and I really appreciate having you on the show.
Thank you for having me. This was great.
So Dan, that was a rock and roll show. I like that.
Yeah, really interesting to talk to Rand. A great guest, and he knows about so much different stuff. I mean, as you said, we probably could have gone off into all kinds of different directions there, but we tried to kind of keep it focused on the whole privacy thing. I do think it's a really interesting time right now for the whole privacy. I loved his point that he made about developers deciding on the technology that gets used, and all of these kind of arguments that are going on right now about privacy. I did very quickly want to mention, I know I'm jumping to plugs here, which is terrible.
No, please go for it.
But I did want to quickly mention, I mentioned at the start of the show about the stuff that's going on legally in the UK right now. There's stuff going through Parliament to try and enforce people to open up their encryption and so on. If you want to know about that, or you want to find out more, there's the Open Rights Group, which I'm a member of. It's a lobbying group in the UK who lobby the government on these kind of issues, and they're much more knowledgeable than I am. But if you go to openrightsgroup.org, if you're in the UK or you care about policy in the UK, I would say check out Open Rights Group. They're doing some great stuff about the online privacy bill right now. Online safety bill, sorry, not the online privacy bill. That's what it's called.
Yeah. It's I may have mentioned this before, but I kind of knew a former chairman of the FCC in the US who said that he'd met with every member of Congress, and the two things none of them knew anything about were technology. and economics. So, and asking them to make laws. Oh my God, it's probably not a whole lot different in the UK. Well, thanks for that. Next week, we will have Bruce Perens on. Bruce is one of the original real major figures in the open source movement. He's not the one who actually named it, but he's the first one to kind of get the ball rolling. But his focus lately is on space. I'm on a list or two with him, and he knows so much about it. There, I'm looking at the back channel here. We're thanking each other for this and that. So everybody, come back next week. Bruce Perens will be on. He's always good. We were going to have him on last fall. Health stuff showed up, and we had to move him around a bit. But he's going to be on next week. It'll be really great. So come back then. Until then, I'm Doc Searls. Thanks for being with us.
Hey, I'm Rod Pyle, editor-in-chief of Ad Astra Magazine, and each week I join with my co-host to bring you This Week in Space, the latest and greatest news from the final frontier. We talk to NASA chiefs, space scientists, engineers, educators, and artists, and sometimes we just shoot the breeze over what's hot and what's not in space, books, and TV. And we do it all for you, our fellow true believers. So whether you're an armchair adventurer or waiting for your turn to grab a slot in Elon's Mars rocket, join us on This Week in Space and be part of the greatest adventure of all time.